Hi there. In this video, we're going to talk about polynomials. We're also going to talk about some of the terminology that goes along with polynomials. Polynomials are incredibly important in mathematics and in the physical sciences. Every linear function is a polynomial. So for instance, to convert from Celsius to Fahrenheit temperature, we would use a polynomial. Areas and volumes are given in terms of polynomials. So for instance, the area of a circle is a polynomial. If we throw an object into the air and measure its height as a function of time, that's given by a polynomial. Polynomials are also very useful for approximating more complicated functions. In fact, when we need a computer to use, for instance, a trig function to do a computation, what usually the computer will do is it'll cheat and actually just approximate that trig function using a polynomial. But you can get such a good approximation that for the use that's intended, you would never notice the difference. And so polynomials are very important to us. So let's learn more about them. So here we see the definition of a polynomial. A polynomial is an expression involving various powers of x. And we see the powers of x range from x to the 0 up to x to the n. Now, you don't see an x to the 0 here because any non-zero number raised to the 0 power is just equal to 1, so we don't need to write it. X to the 1 is just the same thing as x, because anything raised to the first power is just itself. So we have x to the 0 up to x to the n, and each of these x terms are multiplied by a coefficient, right? So the coefficients are just numbers, and we label them a0 up through an. So these can be any numbers at all. We do insist that the an term not be 0, all right? Because we need it to be there so that we know how high these powers go. If the an term was 0, then that term wouldn't even exist, all right? So we assume an is not 0. The largest exponent you see here, in this case it's the n, is called the degree of the polynomial. So if anyone asks you for the degree of the polynomial, you just look for that largest exponent, and that's the degree. The coefficient in front of the highest power of x is called the leading coefficient, and that's important. Sometimes we'll want to know what is the leading coefficient. It says a lot about the polynomial. All right, so let's just see if we can identify whether a function is a polynomial or not. All right, so I've got some examples here, and I've got to scoot over. So the question is this a polynomial? We have this expression. It's not immediately in the form that we said a polynomial has to be in, so let's see if we can get it into that form using a little bit of algebra. Well, you certainly can. I can rewrite this as -1 plus 0x plus 0x squared plus 5x cubed. These things are equal, and we see the one on the right is in the form of a polynomial, and so therefore this is a polynomial. It's a polynomial of the third degree. Remember, the highest exponent is the degree, so in this case the degree is 3, and the leading coefficient is 5. All right, let's go to the next one. All right, here we have something else. This is not in the form that we said a polynomial needs to be in, but let's see if we can do the same thing and use a little bit of algebra and write this in that form. Well, if I just multiply this out, well, then what do I get? Well, I get x squared minus x minus 6. All right, do a little bit of rearranging. It's -6 minus x plus x squared. And so, yes, it is in that form. It is in the form that a polynomial needs to be in, so this is a polynomial. The degree is 2, and the leading coefficient is 1 in this case. Let's go to the next one. No, it's just a number. The number 8 is just a number, a polynomial. A lot of people say, no, this is just a number. But let's look at that definition for what a polynomial is. Can we put it into that form? Well, yes, actually we can. This is a 0-degree polynomial. So we just have one term. It's the a0. You can think of that as a0 times x to the 0, but x to the 0 is just 1. So it's just a 0. And so here the degree is 0, and the leading coefficient is 8. So numbers themselves are polynomials of 0 degree. Let's look at this one. 4 minus x squared over x. Well, I got to do some algebra to put this into that form. We've got division here, and there was no fraction in our definition for polynomial, so let's distribute that x across. So we can write this as 4 over x minus x when we simplify it. Well, that 4 over x term is troubling. I could write that as 4 times x to the negative 1, but notice that negative exponents are not allowed in the definition of polynomial. So this is not a polynomial. Can't have negative exponents. Let's look at this one. 4 minus x squared over 3. Well, again, it's got this division, so right now it's not in the form of a polynomial, but what can we do? We could distribute that 3 across. So we have 4 over 3 minus 1/3 x cubed. Is that a polynomial? Well, that's the same thing as 4 over 3 plus 0x plus negative 1 times x squared. And so, yes, that is a polynomial. So that works just fine. Let me do one more here that I didn't have written down. I'll just write it down right now. Here, let me scoot this up, and I'll write it in here. Let me do, let's do 4 plus 3x minus 2x to the 3 halves. Is that a polynomial? Well, it really looks like it's in the form that the definition needs, except that this guy over here, this exponent, is not an integer. And the way that this thing is defined, we see we're counting 1, 2, 3, 4, etc. for the exponents. They all have to be integers. Since this is non-integer exponent, this is not a polynomial. And I just realized I did have one more on my list, so let's go to that one. So this is not a polynomial. Let's go to the next. Here we have 3 root x plus x. Is that a polynomial? Well, I can write that root x as x to the 1/2 power, right? And now we see we have the same problem we just had in the last example. Non-integer exponents aren't allowed for a polynomial, so this is not a polynomial.